Right, this is Honors Algebra 2 Pre-Calculus. We're doing homework review. This is 10.4 in Pre-Calculus. We're doing number 3 on page 773. So we're asked to find the equation of a hyperbola, given that we know the foci are 0, 0, and 8, 0, and that we know the asymptotes of this function. So there's a couple things. So there are both of these pieces of information, are enough to give me the center of this thing. Because I could either look and realize that the center has to be halfway between the foci, right? And I can graph those if it helps. Like, it's not a bad idea to have an idea of what this looks like. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's a focus here and there's a focus here, which means the center has to be halfway between them. So your center is definitely 4, 0. So you can see that from the foci. But you could also see that from the asymptote, because remember, the asymptote is y minus k equals plus or minus whatever that slope is, right? In this case, it's a 2, and this would be x minus h. So you can see that the h is 4 and the k is 0. So either way, from either of these pieces of information, the first piece of information you get is that your center is at 4, 0, right? The second piece of information you get from the foci. Because the foci, so from this foci I get, from the foci I get that since the foci are oriented in the x direction, right? So the foci are in the x direction, right? So from that, I get that that is also the direction of A. So C, which is this measurement of 4, right? C, which is 4, and A, which I don't know yet, are in the x direction. Okay, so right away, what that tells me is I want something that says x minus h quantity squared over a squared minus y minus k squared over b squared equals 1. Well, once I know that that's the variety of this equation I want, that I want the x's in front on top of the a squared, once I know that, right, now all I have to do, I know h and k already, all I need is a and b, right? So in order to find a and b, so this is definitely the equation I want, and I know h is 4 and k is 0, so all I need is a and b. In a hyperbola, the way you relate the foci to the vertices to the not vertices, or whatever you want to call them, is that a squared plus b squared equals c squared, sort of like Pythagorean theorem. So right now, that's enough to tell me that a squared plus b squared is a 16. And you might be like, oh, cool, Hogan, that's great, but it's still not helping me, right? Because I got that because c squared would be 16. So here's the other relationship that you need. Since a, right, so wherever the asymptotes are, right, whatever the asymptotes are doing, right, they're going to go over a units and up b units, because a is in the x direction, which means b is in the y direction. So what's important here is that a is your run and b is your rise, right? Because it matters which one is in the x direction, which one's in the y direction. So this slope, which is 2, doesn't matter if it's plus or minus, I know that that slope, right, that rise over run, which is 2, has to be b, which is in the y direction, the rise on top of the a. Now that I know that 2a is b, I can actually plug back in and say, cool, a squared plus 2a squared, which would be a 4a squared, right, because it'd be 2a quantity squared equals 16. 5a squared is 16. So a squared, the thing that's going to go on the bottom here, must be a 16/5. Now that's great, but now I need b squared, right? Well, I know that b squared, if I square this whole thing, 4a squared is the same as my b squared. So a 4 times this thing, so my b squared should be a 4 times my a squared, which would be a 64/5. So what that ends up happening, like the answer that we end up getting, there's one of 2 options for this answer. I'm going to erase what this looks like here. One option is to leave a fraction in your fraction and say that your answer is x minus 4 quantity squared over this 16/5 minus y minus 0 quantity squared over this 64/5 equals 1. And there's nothing wrong with that. But if you're like, man, I really hate this whole fraction thing and I'm really not loving the fraction in a fraction, you can flip those 5s up top. So the answer the back of the book has is an x minus 4 quantity squared with a 5 in front all over a 16 minus, and then they don't bother to put the y minus 0, they just had a y squared. So a 5 times a y squared, but you could leave it as y minus 0 squared in that parenthesis over a 64 equals 1. So either of those answers would be fine. It was definitely a tricky problem because of the fractions, but there you have it. That's 10.4, number 33.